Say we draw a straight line. Now let's assume that this line has a length. That seems pretty intuitive from our day-to-day thinking, right? It doesn't matter what that length is though, so don't worry about numbers or distance or anything. In fact, forget about rulers, protractors, and all of that too. We don't need it, and it'll only cause confusion. Even though we're not using numbers, we still need to give this line a name. So let's call it a radius. I mean, it doesn't really matter what you call it. We could call this line smiley face emoji if we wanted to. As long as we know that smiley face emoji refers to this specific line, then we're fine. All right, now let's take radius, and rotate it around like this to draw a new line, which we'll call circumference. Super creative, I know. Awesome, now we've got a circle. And because we made this new line, circumference, from our first line, radius, we can uncover some interesting properties about our circle. See, because we drew the circumference by rotating our first line like this, we know that this end of the radius line never moved. On top of that, because we could have stopped rotating our radius at any time, we know that if we draw another line from that end to any point on the circumference, then any of those new lines would always have the same length as our radius. So all lines drawn from this point to the circumference have an equal length, which means that point, at this end of our radius, must be the center of this circle. So what would happen if we drew a new line like this? Well, this new line is just a continuation of our radius. We know that any line from the center of the circle will have the same length as our radius, so a line twice as long as our radius would stretch from one end of the circle to the other, essentially cutting the circle in half, and this is exactly what we have. In fact, this new line, which we'll call diameter, always cuts our circle into two equal halves. Interestingly, whenever we change the length of the circumference, we also change the length of the diameter. This is because the diameter always has to cut our circle into two equal halves. This is how we've defined the diameter, stretching from one side of the circle to the other. So it must get longer or shorter whenever the circumference gets longer or shorter. Otherwise, it would no longer stretch from one side of the circle to the other. There is a constant relationship between the circumference and the diameter. Changing the length of one necessarily changes the length of the other. And that relationship between those lines, that is pi. That relationship is constant. It's always there. And because it's constant, we can use it to find all sorts of other patterns. Why not cut the circle into 4 equal parts instead of just 2? Continuing with this line of thinking, we can begin creating angles. We could just flip one half of the circle like this and create a wave, and now pi can help us with wave functions. And some of you are probably thinking, why does any of this matter in the real world? Well, the actual concept of pi may not matter to your particular career or interests. Even if it did, you may not find it very fascinating, and that's totally okay. But what's important here, what certainly matters to you in the real world, is that we've used logic to find an actual truth about the world, albeit a mathematical truth. We began with a few assumptions and a single straight line, and had we continued, we would have eventually reasoned through the geometry that brought about the incredible architecture of civilizations like those in ancient Europe, all without a textbook, calculator, or any kind of memorizing. Thanks for watching ADD Philosophy. Sources for this video are in the description, and you can subscribe by hitting the logo in the center of the video. Also, let me know in the comments if you'd like more math explanation videos, because I enjoy doing them. I don't believe math is about memorizing formulas and equations, so I try to go through the reasoning behind the concepts instead. I'm curious to see if this approach is any better. Thanks again. See you all next time.